on just a second. This is section 404, problem 20. Sine of 2 theta
equals sine theta.
Is this a proof?
I don't know.
Okay.
Gotta verify it.
Verify it, so it is an identity. Equals sine theta.
Plus cosine theta, and all that is squared.
Oh, okay, cool. Yeah, we can do that. And all of this is squared.
And then
Minus 1. All right, so we're going to square sine theta plus cosine theta. That would give us what? Sine squared of theta plus 2 sine theta cosine theta plus cosine squared theta. And then we've got this minus 1 hanging around. All right, so where we get that from is sine of theta plus cosine of theta times sine of theta plus cosine of theta. And I can promise you at some point on the test you'll have to do this somewhere. This is an important skill, being able to manipulate these trig functions. Sine of theta times sine of theta, that's where we get the sine squared of theta. Sine cosine plus another sine cosine, that's where we get the 2 sine cosine. And then cosine times cosine is cosine squared. So that's where that comes from. Okay, y'all good with that? Now, what we need to do is look for identities. Do we have any identities here? What is sine squared of theta plus cosine squared of theta? That's 1, isn't it? So I've got a 1 plus 2 sine theta cosine theta minus 1. 1 minus 1 is 0, so I've got 2 sine theta cosine theta, which is one of our identities. That is the sine of 2 theta.
So on the test, could we just leave it sine 2 theta equals 2 sine theta times cosine theta?
Yeah, I would allow that because that is one of your identities, right? But I don't. Is this hard? I mean, now that you've seen it, is this difficult? I mean, if I do any double angle identities, it'll be just like this. I think this same problem may actually be one of your review sheet problems. Okay. What else? What's next? Yes.
Can you do 26?
I can. 26. What is 26?
Cosine 2 theta.
All right, hold on just a second. Let me stop this recording. Okay, number 45 would be what? Read it.
Sine x equals 7 over 25.
Sine x equals 7 over 25.
And then 0 degrees is less than x, and then less than 90.
What is that telling us?
It's in first quadrant.
X is in the first quadrant. That's exactly right. So that's X is in the first quadrant. And that's going to kind of help me know some things about whatever I'm about to try to find. Now, what are they telling us to find in this? Is this a double angle or a half angle?
Find the exact value of sine 2x, cosine 2x, and
Sine 2x, cosine 2x, and tan of 2x. Cosine and sine are really similar to each other, you know, the identity-wise. Tan 2x, probably not going to ask you any of these identities on the test. The tangent, double angles, just one extra step involved, but we'll look at that one anyway. What I need to know here is where the angle is. It's in the first, X is in the first quadrant. Right? That means 2x is going to end up being in which quadrant?
I think it's in the wrong quadrant.
What?
It's pi over 2 is less than x less than pi.
Oh.
I already did the wrong one.
Well, thanks, Garrison. All right, so pi over 2 and pi here. And that means we are in quadrant 2.
No.
Right? Now, sine of 2x is equal to plus or minus 1. Is this right? No, this is x over 2. I'm using the wrong identity. There's no plus or minus in this formula. Kaylee's face was like, no, that's not it. 2 sine x cosine x. All right, 2 sine x cosine x is what we're working with. I am given the sine of x, so I need to find the cosine of x. X is in quadrant 2, and the sine is 7 over 25. And that means that the adjacent side is what?
I got -24.
-24? Sounds feasible. Somebody else confirm that? I do think that's a Pythagorean triple. 7, 24, 25 is a Pythagorean triple. So we've got 2 sine of x is 7 over 25. Cosine of x is -24 over 25. So whatever that ridiculous number is up top, 14 times 20, -24. What is it? What's 14 times -24? Anybody? Somebody? Nobody has a calculator out. .48 times 7 is 280 plus 48, 328. No, that's not right. It's got to end in 6. 48 times 7 is 280 plus 56, 336. Is that right? That's what you got?
Well, like, I just didn't know what to do after I got all that. I just didn't plug it in.
And that's a really ugly answer, right? That's what you kind of get these. I mean, it's such a dissatisfying one of those numbers you get. You say, this can't be right. I've never gotten an answer in a math problem like this in my entire life. But yes, it's correct. All right. Cosine of 2x. If we're going to find the cosine of 2x, we need to choose one of the cosine of 2x identities. What are those? Cosine squared minus sine squared. 1 minus 2 sine squared is one of them. Is that one of them? So for cosine of 2x, because we know sine x, we wouldn't even need to do the triangle to find the cosine of 2x if we use this identity. Right? Because we already have the sine of x. So this would be 1 minus 2 sine of x squared. That is 1 minus 98 over 625. That is right. 7 squared is 49. 49 times 2 is 98. Yeah. So get a common denominator. This would be 625 over 625 minus 98 over 625. 625 minus 98 is 527 over 625. I don't even want to know if that can be simplified. I don't think it can. All right. And let's skip the tangent of 2x. I can assure you I'm not going to give you one of those on the test. I mean, at this point, it's all just a matter of finding the identity and plugging it in and then simplifying the answer. All right. Actually, hold on just a second. Let's do find the tangent of 2x. But let's do it by sine of 2x over cosine of 2x. Isn't that the tangent of 2x? What answer did we get for the sine of 2x? Well, that first answer. -. negative 336 over 625. And this answer is 527 over 625. So the sine over the cosine, the 625's cancel, and we're left with negative 336 over 527. That's the tangent of 2x. So it's really pretty easy to find just using the sine over cosine identity for tangent of 2x. All right? Any other questions? Some of those down at the bottom that a lot of you skipped or didn't do, have we done any of those? Was that one of them?
Create 51.
Sure, 51. What is 51?